Data science. You hear that term everywhere, right? But what does it actually mean? Well, today we're going to connect some pretty wild dots. We'll go from a single student trying to figure out their career all the way to how data is being used to tackle some of the biggest, most complex challenges on the entire planet. So think about it. What could a student's career choice, melting Arctic ice, and your own personal health possibly have in common? I mean, they sound completely unrelated, but there is a common thread, and you've probably guessed it by now. It's all about data. Or more importantly, it's about the incredible science of how we put that data to work. Okay, so where does our story begin? You might think it's in some super high-tech lab, right? Nope. It actually starts with a question, a big one. The kind of question that thousands, probably hundreds of thousands, of people ask themselves every single year when they're trying to figure out what's next. And this is from a real student online. They're thinking about a more technical degree, and they're looking right at data science. You can feel the uncertainty, right? They're drawn to the idea of using tech skills to solve actual practical problems, but they're standing at this classic fork in the road, really trying to get a handle on what a career in data science even is. And that actually brings us to a really important distinction. See, on one side of that fork, you've got something like computational social science. Think of this as the academic, research-driven path. It's all about using computational tools to explore big social questions. But on the other side, you've got data science. It's kind of like the industry-focused sibling. It's less about just asking the questions and more about building the answers. It's all about using data to create real, tangible solutions for businesses and organizations. Okay, so if data science is all about building these solutions, what do you actually need in your toolkit? I mean, what does it take to become one of these builders? Well, the field is moving incredibly fast. So let's look at what the roadmap really looks like for someone who's just starting out today with their eyes set on, say, 2026. You can kind of break this whole journey down into 5 main phases. First up, you have the foundation. This is non-negotiable. It's about mastering the absolute fundamentals, things like Python, SQL, and statistics. From there, you level up to become the predictor. This is where you start building models with machine learning and deep learning to forecast what might happen next. Now, phase 3, the hybrid, this is where things get really cutting edge. You're using AI agents and something called retrieval augmented generation, or RAG. But, a model is pretty useless if it's just stuck on your computer. So that's phase 4, the engineer. This is all about MLOps, getting your models deployed and working in the real world. And finally, once you've got all that down, you become the specialist, where you go super deep into one specific area that you're passionate about. All right, let's double click on that term from phase 3, RAG. You're going to hear this one a lot. It's a total game changer. So imagine you've got this super powerful AI that's basically read the entire public internet. RAG is like handing that AI a special key that unlocks all of your company's private internal data. All of a sudden, that AI isn't just generally smart. It becomes an expert on your specific business. The answers it gives are suddenly private, up-to-date, and incredibly relevant. And what about MLOps from phase 4? Okay, this is the part that isn't always glamorous, but it is absolutely crucial. You see, a lot of data science can feel like a cool experiment, but MLOps, that's what makes it ready for the real world. It's the discipline that makes sure a machine learning model doesn't just work one time on a developer's laptop, but that it works reliably, at scale, for thousands of users, without breaking. Honestly, it's the difference between a neat prototype and a product that actually creates value. All right, so now we have the toolkit, we have the roadmap. Let's see what this stuff can actually do. We're going to scale way up now from an individual career path to a global challenge. We're going to see how these very skills become an incredibly powerful weapon in the fight against one of the biggest threats we face, climate change. The Alan Turing Institute said it perfectly. The future health, wealth, and safety of our species is intimately linked to the fate of our planet. And when you think about it, the problem of climate change is, at its core, a data problem. The sheer scale, the complexity of it all, it's the kind of challenge that is tailor-made for data science and AI to tackle. And if you want to see that change in action, look no further than the Arctic. I mean, this place is warming up 4 times faster than the rest of the globe. Let that sink in for a second. And because of that, trying to accurately predict what's going to happen with the sea ice, well, with the old school methods, it's been next to impossible. And that's where a tool called IceNet comes into the picture. It was developed by a team of researchers, and it's the very first AI model to apply deep learning to this specific problem. Just imagine what that means. You can feed an AI decades of climate data, decades of satellite images, and essentially teach it to see patterns in the ice that were just invisible to human eyes before. And the results? Honestly, they are stunning. It's not just that IceNet is more accurate, it's that it is unbelievably faster. Get this, it runs 2,000 times faster on a normal laptop than the traditional physics-based models could run on a giant supercomputer. That is the kind of leap we're talking about. That's the power of this new data science toolkit in action. Okay, so we've seen the planetary scale. Now let's zoom all the way back in, right down to the personal level, because the exact same data-driven thinking that's helping us understand Arctic ice is also completely revolutionizing healthcare, a field that, let's face it, impacts every single one of us. The amount of data the healthcare industry creates is just mind-boggling, a complete tsunami of information. And it's coming from all over the place. As you can see here, the biggest piece of the pie, about 77%, is what we call human-generated data. Think electronic health records and doctor's notes. But then you have these other growing slices, data from web services, and, this is a big one, all that biometric data coming from our smartwatches and other wearable devices.
So what's the point of collecting all this data? Well, the practical applications are already changing the game for patient care. We're talking about things like spotting disease outbreaks way earlier than we could before, or optimizing how a hospital runs to cut down on wait times and costs. It's even used to catch things like medical insurance fraud, and it's helping with everything from mental health treatment to tracking the side effects of new drugs. Every single one of these isn't just a small improvement, it's a massive step forward.
So let's just take a step back for a second. We started with one student's simple question. We looked at the modern toolkit they'd need to build, and we saw how that toolkit can be applied to massive global problems like climate change and deeply personal ones like our health. It's pretty clear, right? Data science isn't just some buzzword. It is a genuinely powerful force that is actively reshaping our world. But, and this is a really big but, all of this power comes with some pretty serious challenges. For starters, a lot of this data is just a mess. It's unorganized, it's inaccurate. Then there's the huge issue of privacy. How do you use sensitive patient data while also protecting it fiercely? And on a technical level, just getting data from different sources to talk to each other is a constant struggle. These aren't small hurdles. They're the big, complex problems that the next wave of data scientists will have to solve. And that really brings us to the final, critical question. We've established that we have this incredible tool, right? Something powerful enough to help us tackle climate change and revolutionize medicine. The potential is just off the charts. But the real question is, are we as a society ready to manage that power responsibly? Because the answer to that question, well, that's what's going to define our future. Thanks for digging into this with us today.